Part 3 of our slope series is about the equation of a line. Earlier on, we spoke about a line that either is direct variation or partial variation. We talked about this being the constant of variation. It's the number that we multiply by to get our y value. We multiply this number by every x value and we get the y. In this case, it was also the constant of variation. But here we didn't have a start at the origin. We had a b value, what we called the y-intercept. Now, if I look at the last graph that we had just done in part 2, we've done this here. And we looked at the slope and we found the slope, which was -2. And if I were to remember what we said, if you remember what I said about a y-intercept is when x is equal to 0. If you look at this graph, where is x equal to 0? What point do we have? Well, x is 0 here. Well, what is the y value when x equals 0? There it is right there, 20. That is 0 and 20 is our point. And so this one here would not be a direct variation because we are starting at 20. And so our equation would equal mx plus b, where m is the slope, which we found, and it's -2x. And then 20 is our y-intercept. We can check and see if this works. Let's take a point on the graph. Here's a point 8 and 4. If I plug in 8 into here, I get -2 times 8, which is -16. Let's try that. Let's write it out. So y is equal to -2, and then I will plug in the 8 and add 20. -2 times 8 is -16, plus 20 is 4. Is that the correct y value? Yes, it is. So we have correctly found the equation of this line. You can find the equation of any line as long as you know the y-intercept and the slope. Once we know that, any equation of a line can be found. Remember, if you don't have a y-intercept, or rather if the y-intercept is 0, this is what your equation of the line looks like. Otherwise, it looks like this. And this is called y equals mx plus b. And this form will be used over and over and over to find the equation of a line. So let's look at some other examples. If we are given the point 0, 0 and -2, 5, let's label them A and B. And we want to know equation of the line AB. So what we need to do is right away, and this is very important, is to write down the equation of a line, which is y equals mx plus b. Now, we need to find, when we're finding an equation of a line, these are the two parameters we're looking for. Find m and b. To find the slope, this is what we do. Now in this case, if you look here, the point is at the origin. And so if it's at the origin, what does that tell us? It tells us that the y-intercept is 0. So we really have this equation, y equals mx plus 0. How do you find the slope? We had different ways. Rise over run with a graph. In this case, we don't have that. So the other thing that we used was y2 minus y1, or the differences in the vertical distance divided by the difference in the horizontal distance. And so in this case, let's assign these values. Let's call this x1, y1, x2, and y2. And so I'll plug them into here. And what I will have is 5 minus 0 over negative 2 minus 0. And therefore, the slope is 5 over negative 2. Once I know this, I can just plug into my equation. We had decided that this was the one we were going with because it was a direct variation. And so now what I have is y is equal to negative 5 over 2x. And that's what I have as my equation of my line. This was fairly straightforward because we went through the origin and we didn't have the y-intercept. But let's see what happens when we change this. Let's try a different one. If we wanted to find the equation of a line going through the point A at 3, 0, and the point B at negative 2, 5. So the equation of a line, always write this out first. We want to find M and we want to find B. Now this is a little more complex because there is a B value, or we assume there is because we don't have a point that's the origin at this point. So let's figure this out. We'll start by finding slope. And slope is also written, slope is also M. And so I can say M is equal to y2 minus y1 over x2 minus x1. And that gives us 5 minus 0. I'm going to label them again so that you know where I'm getting these numbers. I just labeling them the first point and the second point. And that's over negative 2 minus 3. And this equals 5 over negative 5. And we can reduce that. M equals 5 divided by negative 5, negative 1. And so this is our slope. Now for an equation of a line, we need the slope and the y-intercept. How are we going to find this y-intercept? What you do then is you take the slope and plug it into this equation. And then to find the b, you need to have one variable, but then you have an x and a y. What you can do is use any of these 2 points to plug into this and find your b value. So let's start with putting in m equals 1. So we've got y equals negative 1 x plus b. That's what we have so far. And in order to find the b, and we want it to isolate one variable, let's take an x and a y. An x and a y is any point. We can choose this one or we can choose that one, whichever one you like. Let's try this one. So we're going to put in 0 for y, and x is 3 plus b. And so you have 0 is equal to negative 3 plus b. Bring the negative 3 over to the other side. Becomes a positive 3, and so b is equal to positive 3. And finally, the equation of the line is equal to mx plus b, and so we fill in what we need, the m negative 1x and the b plus 3. In order to check to see if we have the right answer, we can use this equation and plug in now this point. If this point works in this equation, then we have done a good job. So let's try and do that. Let's plug that in. We have y is equal to negative 1x plus 3. And let's see if the left side and the right side match up once we plug this in. So if I plug in the negative 2, y is equal to -1 times -2 plus 3. Y is then equal to 2 plus 3. Y is equal to 5, and that matches. So we have done a good job, and we found the equation of the line that goes through the point 3, 0 and -2, 5.